Hey folks, welcome back. So the last time that we were here, we were talking about different internal threats to validity. We've already talked about history and maturation, and we were finishing up talking about regression to the mean. So just as a friendly reminder of what regression to the mean is, in case you've taken a little break. So generally, we're going to find that if you have an extreme score at one point in time or for one variable, what we're typically going to find is that for the second time point of measurement or for the second variable, odds are pretty good you're going to see a regression toward the average. So like I said in the last lecture, so if we see a soccer game in which one team gets 7 goals, which is very high for a soccer game, odds are pretty good the next time that we see them play a soccer game, they're going to get a number of goals that is probably closer to what we would see in an average game, such as 1 or 2. So, how do we fix it? Well, there are a couple of things that we can do. The first thing that we can do, again, this is a case where a comparison group is going to be really critical. So I mentioned last time that let's say that you were picking a group of people for your depression treatment study, and you pick them on the basis of the pretest results, and you want to pick the people who are the most depressed. Odds are pretty good that's going to be an extreme value. And because of what we know about regression to the mean, odds are pretty good that you're going to see a reduction in that score on the post-test. Not necessarily because of the treatment, not necessarily because they're less depressed, but because of regression to the mean. So a comparison group that does not get the treatment is going to be very critical. And we also need to visually inspect our results and see what's going on. So here are a couple of different scenarios that might help kind of clarify whether or not it's the treatment working or we're seeing regression to the mean. So here's a case where we've got our no therapy group in green and we've got our therapy group in orange. So they both kind of start out at a similar level prior to therapy. After therapy, you can actually see that there's a difference here. Now, with our no therapy group, this slight reduction is due to regression of the mean. But for our therapy group, theirs is lowered further beyond that. So what this shows is that even though they were equally extreme, and we do see a reduction at post-test for our no therapy group, our therapy group does seem to be benefiting from the treatment because these two are different from each other. Here is an instance where we get regression to the mean. Regression is absolutely possible here. So here, our groups are already kind of different from each other from the get-go. And usually when you see two groups that are different from each other at the start, that makes me a little bit nervous, personally, because they're already different to begin with. So because they're different, we can't tell if the differences between groups post-test are because of the treatment or because they were different to begin with. But here, you can see that our no therapy group doesn't really change, but our therapy group does. Now, regression could be possible here because our therapy group was already more extreme than our no therapy group. So extreme pretest scores can be influenced by chance events. Now, here we get a crossover. They're different when they start with our therapy group actually being more extreme than our no therapy group. But the no therapy group stays at the same level, but our therapy group reduces their depression even further. So even though our therapy group started out more extreme, this regression to the mean would not cause a crossover. So because of this, therapy must have had some type of influence. So in both of these cases, if we see data that looks like this, this would kind of suggest that this intervention is working. So now we're going to talk about our next threat to internal validity, attrition. These are basically people that either don't show up for your experiment or they drop out of your experiments. This is what's also known as subject loss. This is a case where participants will fail to complete the study. And let's be very, very clear. If you are running an experiment, particularly if you are doing a longitudinal experiment where you are following up with people over a long period of time, or if there are multiple sessions that they have to complete, you are going to get some dropouts. That is a fact of life. Now, dropouts or attrition can happen for a variety of different reasons. It can happen because of faulty equipment. Whenever I've lost participants, it's because my computer glitches and I can't collect their data. They may drop out because they're bored. They may drop out because they move. If we're doing a longitudinal study, death is another instance of attrition. So here's the thing. Attrition is not always bad, and it is something that you should expect anytime that you're doing a research study. But it can actually threaten internal validity in certain circumstances. In particular, if we see systematic attrition, this is going to be really important. So what if your dropouts are fundamentally different from the people who stay? And this is where it becomes a problem. So for example, let's say that we are doing our depression study with our therapy group and our no therapy group, and it turns out that our group that is getting therapy drop out because the treatment is too hard. And it turns out that everybody who's dropping out in the treatment group is more depressed than the people who are staying. That creates a difference in our data, and that's going to fundamentally change our data as well. So how do we prevent? So if we lose people before they actually take a post-test, we need to remove their data from the pre-test average as well, because this can really mess around with group averages. So if somebody drops out before you can take their post-test data, get rid of their pre-test data as well, and document in your write-up of your experiment that this person dropped out. Now, I think this is really important to note, and this is something your book doesn't mention, but I think it's worth noting. Attrition is not always bad. Attrition can tell us very, very valuable things about our participants, and knowing when attrition is likely to occur can be incredibly valuable. So one of the ways that you can think about this, imagine that we are looking at a study that is trying to find if people can successfully quit smoking. And we're evaluating the efficacy of two different programs. We're looking at a 6-week program versus a 12-week program. And we want to see if the smokers are smoke-free a year later. Now, let's say that I look at that data a year later, and there's no difference between the groups. So it turns out that 6 versus 12 weeks is apparently equally effective. But I do find that the 12-week group has more attrition, and most of them are dropping out after 7 weeks. This is really valuable. So this can tell me a couple of different things. It can tell me that longer programs can work, but only if participants stay to the end. And maybe it tells me that if most of my participants are dropping out after 7 weeks, and there's no difference between my groups, that a 6-week program is probably going to be more effective. So it tells us about what programs will be more likely for us to work, for us. So this can be very valuable. Additionally, if you're finding that certain types of participants are dropping out of your study, creating a biased sample of your data, you need to think very carefully about what you can do to make sure that you don't get that kind of dropout with that particular group. So the next one that we are going to talk about, the next threat to internal validity, is testing, or what we call a testing effect. So I want you to think about when you took the ACT, or if you're in my neck of the woods in the South or the East Coast or the West Coast, the SAT. Did you take it more than once? How did you do the first time that you took it? How about the second time that you took it? Generally, what we're going to find is that regardless of a variety of different reasons, you're typically going to do better the second time you take a test than the first time that you took it. I am not a very good example. I took the SAT once. I also took the GRE once. So I'm probably not a very good example, but if you took it more than once, I want you to think back to how you did. One of the things that we will find is that generally measuring responses will affect how people respond on subsequent measures. So generally, part of the reason that this happens is because the first time that you take a test, it's new. It's unfamiliar. You might be a little bit nervous. But by the second time that you've taken it, it's possible that you're more comfortable with the test, you're more familiar with it. And so, because of that, we can't necessarily say when we're looking at pre-test versus post-test if it's because the intervention worked or simply because you're more comfortable with the test. So it's possible that the pre-test experiences affected post-test scores. So maybe you became more familiar with the test and the setting. Maybe you're more motivated to do well. Maybe you're less anxious. Maybe you're getting a practice effect. You're more comfortable with the test now. So that can lead to a reduction, for example, in our depression study. That could lead to a change between pre-test and post-test. Again, this may not be because the intervention worked, but simply because people are more comfortable with the test. So something kind of related to this is what is known as instrumentation. Measuring instruments will change over time. So I'm kind of running up against this right now. I'm learning how to play guitar. Fender is doing online lessons, and so I thought it would be fun to get some guitar lessons. So every time that I practice for a guitar lesson, I pull out my tuner or a pitch detector. And one of the things is the more that I use that, the less effective it's going to be. It's battery operated, and the more that I use it, the more that battery gets drained. So the measuring instrument will change. Its ability to detect a proper frequency will get worse. The same is true with the scale. The more that you step on it, the greater the likelihood that with repeated exposure, the instrument will break down over time. Now, here's what's kind of interesting. Now, if you are using the same inventory for pre and post-test measures, you don't necessarily have to worry about instrumentation issues. You will have testing issues to worry about, and we'll talk about some of the remedies for that. But in the case of our depression study, instrumentation is not a factor. However, if you're utilizing human observation, like in the summer camp study that we saw with the low sugar diet, observation is technically a type of instrument, and observers can get worse or change their measurements over time. So observers could have some instrumentation effects. So our observer could become tired. Our observer may not always appropriately be measuring rowdy behavior every time they see it. They might become ill and not be able to measure as effectively as they could. The first time that our camp counselor measures, he may not be very good at indicating the instances of rowdy behavior, but he's better at the post-test measure because of a practice effect. So instrumentation is not just something that happens with equipment, it's something that can also happen with observers. So let's talk about some of the different ways that we can rule out testing threat and instrumentation threat. So for testing, there are a couple of different things that your textbook recommends. First of all, you can choose to not have a pretest at all, and sometimes that's okay. You can have what is called alternative forms of the pretest and the post-test. So in this case, you're asking similar questions, but they're not exactly the same. So you can rule out practice effects or familiarity. Make sure you have a comparison group. Give them both tests, pre-test and post-test, and make sure one group doesn't have a treatment. For instrumentation, again, we can use a post-test only design. We can make sure that our instruments are constantly calibrated. If we're doing tests, especially if we're doing alternative forms, we can counterbalance our tests. So if we're doing an alternative form, we can give one group form A first, and then they get form B. The other group can get form B first, and then they'll get form A. And for our observers, we can make sure that our observers are constantly being trained and retrained, and that we've got clear coding guidelines. So those are the 6 major threats to validity that we will see for a one group pre-test, post-test design. But one of the things that's important to note is that selection. So each of your groups being fundamentally different from each other can combine with other threats to validity. So just as a reminder, and we kind of talked about this last week, a selection threat occurs when participants that are in different experimental conditions already differ on a characteristic that either partially or fully accounts for our results. So is it because of the intervention, or is it because our groups are fundamentally different from each other? So for example, in our depression study, our therapy group may potentially be more depressed than our no therapy group. That's a selection threat. So we may not see, if we have our no therapy group only being mildly depressed, we may not see much of an increase or a decrease in depression because they're only mildly depressed, and they don't really have too much wiggle room for improvement. They're already kind of at that low grade depression mark, and really they're not that far away from not being depressed. But a group that's getting therapy that's more deeply depressed, they have further room for improvement, and as such, we can't be sure if it's the intervention or because the two groups were different from each other. So this is a case of a selection threat, and it turns out that selection can interact with both history and attrition to create threats that can be possible in one group pre-test, post-test designs. So with the selection by history threat, there could be an outside factor that affects only one level of the independent variable. So for example, your book talks about the Facebook Go Green initiative. Maybe one of our comparison groups had a construction crew renovating in the building. And during that time that the Go Green campaign was going on, they used way more electricity than the other group. So in that case, we don't know if it's because of the intervention or because our groups are fundamentally different from each other. We can also have a selection versus attrition threat. One experimental group experiences attrition, the other group doesn't. Maybe our therapy group in our depression study has more attrition because they find the therapy too difficult, but the other group doesn't. That creates two groups that are fundamentally different from each other, and it changes how we obtain those results. So now let's talk about potential confounding variables for all studies, not just one group pre-test, post-test designs. So if you are running an experiment, we have to talk about observer bias. You generally will know what your hypothesis is ahead of time and what you'd like to find in your data. You've probably already thought about what you'd like to see, what you expect to happen, and this is going to put you at a huge disadvantage. And here's why. It's possible that because you know how you want the results to shake out, you're only going to look for instances that support your results. If you're utilizing observers and they know what the hypothesis of your study is, it's possible that they are only looking and observing instances that fit with the hypothesis that you've selected. So you're basically engaging in confirmation bias. You're only looking at the data that supports your hypothesis, and you're not focusing on all possible data at hand. So your expectations influence how you interpret the results. So how do we avoid these? Well, one of the things that I like to do in experiments is follow a protocol. So especially for my experimenters, people who are helping me run the experiment, I may not necessarily tell them exactly what I am looking for in the study. So I have a very clear protocol that tells them what to say, what to do, how to say it, and how to answer participants' questions. And we also want to make sure that experimenters are as standardized as possible. So we want to make sure that we're not necessarily sending signals to our participants that there's a certain way that we want them to respond. We can automatize instructions. I usually will do this with a computer program. And then the other thing that we can do is what's known as masking or blinding. Because I know what my hypothesis is and what I'm trying to study, maybe I don't actually collect data from participants. Maybe I have other experimenters who do not know the hypothesis or what I'm looking for or what I'm trying to study. Maybe I have them do it for me so that they don't send signals to participants about how they expect to respond. This is what's known as blinding or masking in certain cases.